Hello guys, welcome to this channel once again. This is Zion Tutor, where we make mathematics, further mathematics, your physics question or any topic for we explain so that you can understand the concept behind each topic, and also so that you can have the ability to retain that concept in your mind. Please, if you are new to this channel, don't forget to subscribe, like, and help us share this video. And please, at the end of every video, if you have any question or you want us to explain a topic to you, just go to the comment section and drop the question or the topic. Or if you check the description box below, you will see a WhatsApp number there that you can message to, or let us know maybe it is a question, or maybe you want us to make a video on a particular topic, and we are glad to do so. Please help us to share this across every student that you know that is in science department, or any student that are doing physics, physics further mathematics. So we deal with both Cambridge O level and also Cambridge A level in mathematics and physics. So today in our teaching, we want to look at a topic that says arithmetic progression and geometric progression. Now there is a question. This question now is under arithmetic progression, but if you look at this question, it doesn't seem like a arithmetic progression question. But these are the application question, and this is how Cambridge set most of their question under AP and GP. And so let's go through this question to explain the concept behind AP. AP means arithmetic progression. It can also be called a linear sequence or a linear progression. Now the question here is saying that a hardware store sells nails in a range of a packet containing different number of nails. And we have a store that are selling nails. So they have a packet A containing 50 nails, packet B containing 75 nails, and packet C containing 100, and so on. That's one. That means we still have packet D, we still have E, we still have F, going on like that. So how do we know that this is an AP? You will say that the first packet, which is packet A, is 50 nails. The second packet, 75 nails. If you check the difference, you see it's 25. And when you come to the third packet, it's 100. If you check the difference between the packet C and packet B, you also see it's 25. So they are having the same common difference. So and so on means when you get to packet D, that will be 125 nails. Packet E, that will be 150 nails, and so on like that. So that means this question is an AP, because the first thing we need to know, in AP we have what we call a common difference, our D. So and here from packet A to packet B, we see a common difference of 50. And from packet B and to packet C, we see also a common difference of 25 rather, sorry. So this is an AP question. Now let's just run through a few things that we need to know in AP so that it will give us the leverage to solve this question. Now, in an AP, the first thing that we need to know, we have a letter A, and that letter A we call it first term. That means if you have any question, the first number, now if you have a sequence that's 1, 3, 5, 7, 9. In this now, this sequence have 1, 2, 3, 4, 5 terms. We call it 5 terms. And the first term here is my 3. That means A is my 3. The second term here is, A is my 1. The first term here is 1. The second term here is 3. The third term here is 5. The fourth term here is 7. And the fifth term here is 9. So the first term of every sequence is the first number. That means in this type of sequence, A is my what? First term. And there's another thing that we need to know, which we represent as D. We call it common difference. So for a sequence or for anything to be an AP, it must have a common difference. Like this now. How do we get my common difference? Second term minus the first term. 3 minus 1, which is 2. 5 minus 3 will give me 2. 7 minus 5 will give me 2. 9 minus 7 will give me 2. So that means that's what we call the common difference. the common difference. That difference must be common in that term. So that means the nth term, we call it Tn of our AP, is giving us a plus bracket n minus 1d. Tn is called the nth term. N is called the number of terms. You know our A, which is our first time, and our D is the common. This nth time, sometimes they call it last term. We call it last term. So this is the formula for the nth time of an AP. And also, there is what we call the sum of AP. There is a formula for the sum of AP. For example, we can be given to say that we should find the first 25 terms. So instead of us be getting the first term, second term, and be adding it together, you can just use this formula, the sum of AP, Sn equals to n over 2 into brackets 2a plus bracket n minus 1d. This is the formula. And I can bring out another formula here, because if you check here, our n term, I can write this as the one inside the bracket as a plus n minus 1d. Now if you see a plus n minus 1d is my last term, or we call it nth term. So that means I can say my Sn equals to n over 2 into bracket a plus, you say last term, or your nth term. So you can see this formula in these two versions. That means if you are given a last term of any sequence and the first term, it's easy to get the sum of that term. It's easy to get the sum of that term. Now, because we have known this concept about this, let's now go to that question and solve that question with this little understanding that we have about AP, that we know the common difference, we know the nth term, and we know the sum, so that we can able to apply it. Now, if we check the sequence of this question, the packet A has equals to 50 names. Packet B, 75 names. Packet C, 100 names. If you see that sequence, 50, 75, 100, if you follow our first term here is 50, and the common difference here is 25. You can say 75 minus 50 or 100 minus 75. That means my D here is 25. Now, the question A, under that part, is saying find the number of names in packet J. Now, packet J, what is the number of terms for packet J? Packet J, packet A is 1, packet B is 2. That means n is 2 there. Now, packet J, that means our n, if you can count it, A, B, C, D, E, F, G, H, I, J. I think that would be 10. A, B, C, D, E, F, G, H, I, J. That means my number of terms there is 10. So for me to know the number of names in packet J, it's just Tn equals A plus bracket n minus 1d. That means T, the nth term here is 10 equals, what's my A? 50 plus bracket 10 minus 1, 25. So that means I have 50 plus 9 times 25. That means my 9 times 25 is what? Plus 50. This will be 225 plus 50. That will be 275 names. So that means my packet J, we have 275 names. Now, the second part of that question, it's saying that Shand buys one of each of the packets A to J. How many names in total does Shand have? That means if Shand buy packet A, B, C up to J, now how many names will he have in total? That means what they are trying to just say is that what is the sum of all the number of names from packet A to J? Now if you are beginning to say, since packet A means n equals 1, to be finding it one by one, that would be a stress. So what they are just saying that what is the sum? The S10. Since Shand is buying packet A to J. So that means S10. They are telling us to find the sum of term, which is n over 2 into bracket 2a plus bracket n minus 1d. So that means, and don't forget, our a is still 50, our d is still 25. So that means my S10 is equals to 10 over 2 into bracket 2 times a, that will be 100 plus, this is 9 times 25. So this will be 5 into bracket 100 plus 9 times 25, I think that's 225, if I'm right. That will be 225. So if you add this, that's 325, and if you multiply it by 5, I mean I have 1265 nails. So from packet A to packet J, the number of nails inside it will be 1625 nails. Now to go to C part of the question, the C part is now saying that assuming he buys each of the packets starting from A. Now they are saying if he buys from the packet starting from A, how many packets does he need to buy to have a total? Now they are giving out that the Xn, we don't know the N. Sn is 1100 nails. But we don't know the number of N. That means the number of which packets we make them to have this. If we start buying from packet A, now since we know the Sn is equals to this, it's easy to get. Don't forget our A is still 50 and our D equals to 25. So we are saying Sn, which is 1100, equals to N over 2. 2 times 50 plus 10 minus, no, we are looking for N now. N minus 1 into bracket 25. So if you cross multiply, this will be 2200 equals to N into bracket 100 plus 25N minus 25. This will be 2200, which is equals to N into bracket 75 plus 25N. If I open the bracket with N, so that means I will have 25N squared plus 75 minus 2200 equals to 0. This leads us to a quadratic equation. If I divide through by 25, then I have N squared plus this 75N plus 25 divided by that was 3N, and 25, this will be minus 88 equals to 0. Now looking for a factor that when I multiply we get 88, and when I add, that will be plus 11 and minus 8, plus 11 and minus 8, that will be N squared plus 11N minus 8N minus 88 equals 0. Just use factorization. This will be N in bracket N plus 11 minus 8 in bracket N plus 11 equals 0. N minus 8, N plus 11 equals 0. So our N here will be 8 or minus 11. And since we know that he buys a packet, the number of packets cannot be negative because N will be greater than 0. So that means the number of packets that Shan will buy will be equals to 8. And if you check 8, that means that will be packet from packet A, B, C, A, B, C, D, E, F, G, and H. That's 8. 1, 2, 3, 4, 5, 6, 7, 8. So that will be the number of packets of H. So now the next question will be under geometric progression. Under the geometric progression, we just look at a geometric progression question. Now the geometric progression question is saying that in the 15 days so the Moravia, the cyclist must ride 120 kilometer, and each successive day they ride 90% of the distance of the previous day. Now say A, how far do they ride in total to the nearest kilometer? And the question B says, after how many days will they have riding half that distance? Now if you look at this one critically, you see it forms a GP, a geometric progression. That's in a 15-day Tour de France, a cyclist must ride 120 kilometers, and each successive day they ride 90% of the previous. That means the second day that cycle will ride 90% of 120. The third day you will write 90% of what we get. If you say 90% of 120, you say 90 over 100 times 120. This is like 5, 6, 550 over, it's less than 120. 1. So 18 times 6. That's 108. So that means the third day, 90% of this. If you begin to do it like this, you will be spending more time. That is why you see that. So that means for each term, it's decreasing by 90%, 90%, 90%. That means our, in GP, now in GP, the same thing that we have in our AP, we still have our A, which is the first term. But in GP, instead of us having a common difference, we have what we call a common ratio. And the difference here is that, in our AP, the common difference means that we are going to subtract the first term from the second term. But in the common ratio here, you divide your second term. Let's say our second term is T2 over T1. Or you say T3 over T2. You divide here. And the nth term of our GP is AR raised to the power n minus 1, where our n is the number of terms. And also in our GP, the sum of terms. Now we have two formulas. The first one, when our R, the common ratio, is greater than 1, we have our Sn to be A into bracket R raised to the power n minus 1 over 1 minus, over R minus 1. But if our R is less than 1, we have our Sn to be equal to A into bracket 1 minus R raised to the power n over 1 minus R. So it depends on our common ratio. And these are the things that we apply in this question. Now, in the 15 days, that 15 days is telling us the number of terms, which is our n there, because the competition will last for 15 days. Now, the cyclist, the first day, which is the first term there, is 120. So that means our first term, which is A, is 120 kilometers. And our common ratio will be what? The 90%, we convert it to decimal, and that will be 0.9. So by having that understanding, since we know that our A is equal to 120 kilometers and our R is equal to 0.9. Now the question now says, how far do they ride in total? That means in total means in the whole 15 days, what is the distance that cyclist will cover? I just say your Tn equals to AR raised to the power n minus 1. So this is our formula for our last term. So in the whole 15 days, that means we need to use the sum of term for the whole 15 days. For the whole 15 days. So that means our S15 will be equal to A into bracket. Now look at this. Our R is less than 1. So that means we are going with this formula, which is A into bracket 1 minus R raised to power N over 1 minus R. And that gives us our A is 120 into bracket 1 minus my R 0.9 all raised to power 15 divided by 1 minus 0.9. So if we solve this, that will be, this one will give us, if we press our calculator in this, we have 952.93 kilometers. But don't forget, the question says to the nearest kilometer. So that means to the nearest kilometer, this is what? 953 kilometers. 953 kilometers. That's the first part. Now the second part is now saying after how many days. And they are telling you to find N. We did have reading half of this distance. No, half of this distance now. After how many days? Now, what's the half of this? The half is just 953 over 2. And that will give us 460. Am I right? No, that's 476.5 kilometers. Now, they now say how many days we have this distance. We are still using our sum, and don't worry, our A is still the same and our R is still the same. So that means that Sn for the half of this now, that means we have 476.5 will be equals to A 120 into bracket 1 minus R 0.9 raised to power N. Now everything divided by 1 minus 0.9. If you cross multiply here, we have 476.5. This will give us 0.1 times 0.1 will be equals to 120 into bracket 1 minus 0.9 all raised to power N here. Now, so that means we have 476.5 times 0.1 divided by 120 will be equals to 1 minus 0.9 raised to power N. That means if we press our calculator for this, we are going to arrive at 0.3971, which is equal to 1 minus 0.9 raised to power N. So if you bring our 1 to the other side, we are going to arrive at 0.36029 equals to 0.9 raised to power N. Now when we arrive at this junction, how do we proceed? Just introduce your natural log. And what's our natural log? The same thing, we lean both sides. We say lean in bracket 0.6029 equals to lean 0.9 raised to power N. So that means the same thing as law of log, this power will come, and that means lean into bracket 0.6029 equals to N lean 0.9. That means my N here will just be lean into bracket 0.6029 divided by lean 0.9. Now if we press our calculator for this, if we punch our calculator for this, you will see that our N there, our N will be approximately like 4.8 something. Let me check my calculator, like 4.8023. So that means our N here is approximately equals to what? 5. That means in 5 days, we have a distance. We have this distance. That is the solution to the question. Please, if you have not subscribed, don't forget to subscribe, to like, and help us share. And if you have any question, go to the comment box below or go to the description. You will see a WhatsApp number there that you can message to drop your question or a topic. Thank you.